So we have covered neural pathways that run from a receptor up the spinal cord to the brain and then back down the spinal cord out to an effector. But we also have other forms of neural pathways which involve a sensory receptor and motor component, but the pathway doesn't actually reach the brain. This type of neural pathway is called a reflex or a reflex arc. And in this learning objective, we're going to cover the components of a reflex arc, how we classify reflexes, and some specific examples. So a reflex is a rapid, involuntary response to a stimulus that occurs automatically without conscious thought. When we consider the makeup of a reflex, it looks similar to or contains the same components as any other neural pathway, but the major difference is that the integration site of the sensory input is in the spinal cord and not the brain. The benefit of having the integration centre in the spinal cord means that our reactions or outputs can happen quicker and no conscious thought needs to be involved. When we consider many of our reflexes serve as protective functions, for example, how we reflexively pull our hand away from something that's hot, it's beneficial for this action to happen as quickly as possible and without the need for us to be actively thinking about it. So a typical reflex arc will consist of a sensory receptor, which responds to a particular stimuli, a sensory neuron, which conducts that information towards the integrating centre, the integrating centre, which will sit within the spinal cord. Now that can be an interneuron, like we've got here. So an interneuron is just the neuron in between a sensory neuron and a motor neuron. Or the integrating centre can be the synapse directly between a sensory neuron and a motor neuron. We then have the motor neuron, which propagates the information or the motor output towards an effector. And then our effector, which is typically a muscle or a gland that carries out the response. Now, because we like to classify everything in anatomy and physiology, there are a number of ways in which you can classify a reflex. For example, you can classify the reflex based on whether it's an innate reflex in that you're born with it, or an acquired reflex, which you do learn, but it becomes reflexive over time. So as an example of an innate reflex, there are many reflexes in babies. For example, the Moro reflex, which is where the babies will fling their arms out to the side if they feel like or they actually are being dropped. Or the rooting reflex, where a baby will turn its head and open its mouth if you stroke its cheek. So this helps with the early stages of feeding. An acquired reflex is something like riding a bike, whereby once you have learned how to ride the bike and you have experience riding a bike, it's actually very difficult to unlearn this skill. And when you're sitting on top of a bike, you start to ride it without really actually thinking about it. We can then classify reflexes based on where the integrating centre sits. So we can have cranial reflexes, which is when the integrating centre sits in the brainstem. So this is involved in reflexive movements of the eyes, for example, that happen as you're reading. Or a spinal reflex, which is where the integrating centre sits in the spinal cord and usually involves structures lower down in the body, such as your arms and your legs. We can classify reflexes based on the nature of the response. So for example, a visceral reflex will involve an organ or a structure that we cannot consciously control, such as when the pupil of the eye constricts or gets smaller when you shine a bright light. Or a somatic reflex, which will involve a skeletal muscle and includes things like the stretch reflex, which is when the doctor taps just below your knee on your patella tendon and your leg will kick out. Reflexes can be classified based on whether they involve one side or both sides of the body. So an ipsilateral reflex involves a sensory receptor and a motor neuron and effector on the same side of the body. A contralateral reflex will involve a sensory receptor and sensory neuron on one side of the body and a motor neuron and an effector on the other side. And lastly, we can also classify reflexes based on the number of neurons and therefore the number of synapses involved in a reflex arc. So a monosynaptic reflex, with mono meaning one, occurs when a sensory neuron synapses directly with a motor neuron. So there's only one synapse in that reflex arc. A polysynaptic reflex, with poly meaning many or more than one, is when there might be an interneuron, so you have at least 2 synapses in that reflex arc, or when one sensory neuron might synapse with more than one motor neuron. Now, 2 specific reflexes that we're going to walk through now, and I want you to be aware of due to their relationship to some of the sensory receptors that we talked about earlier, are the stretch reflex and the tendon reflex. So a stretch reflex causes contraction of a skeletal muscle, which is our effector, in response to the stretching of the muscle, which is the stimulus, and is detected by a muscle spindle, which is the receptor. So we will have a go at this in class, but stretch reflexes can be elicited by tapping on tendons attached to the muscles at the elbow, the wrist, the knee, and the ankle joints. This is because when you tap on those tendons, it kind of bends that tendon in and it will stretch the muscle that it's attached to. Now, the most common example of a stretch reflex is the patellar reflex or the knee jerk reflex. And so I'll walk you through that process in this image now. So we've got a reflex hammer and we're tapping on this patellar tendon here. When we tap on it, it will push that tendon in and it will stretch this quadricep muscle, which contains our muscle spindles. So remember, our muscle spindles are proprioceptors that detect change in muscle length. When that muscle is stretched, it will send this sensory information along the sensory neuron into the spinal cord. Now, this sensory neuron can synapse directly with a motor neuron. That motor neuron carries the motor information back down to the same muscle. And what it tells that muscle to do is actually contract. So when a muscle contracts, it gets shorter, and it's like the opposite of stretching. So it relieves that stretching. So this part here can be one of our reflex arcs. However, depending on where this stretch reflex takes place, that sensory neuron can actually synapse with either another motor neuron or an interneuron and then a motor neuron. And in this example here, it's innervating the hamstring muscles. And here it's telling our hamstring muscle to relax. So if you think you want to contract your quads, you need your hamstring muscle to relax to actually allow for that contraction. So this reflex can either be a simple monosynaptic reflex or a polysynaptic reflex, depending on where in the body it takes place. We then have our tendon reflex, and our tendon reflex works to protect our muscles and our tendons by forcing that muscle to relax before the muscle tension or the muscle force becomes so great that we're actually going to do damage to that muscle or the tendon. So in this example, the sensory receptors are our Golgi tendon organs. And remember, these receptors detect and respond to changes in muscle tension. So we've got our Golgi tendon organ here, sitting in the tendon that attaches our quadricep muscles to the patella. And let's say we're doing a really strong leg extension, so we're contracting this muscle really hard. It's causing a change in tension in the tendon, and this is detected by our Golgi tendon organ. This sensory information is then transmitted into our integrating center in the spinal cord. Here we're connecting to an interneuron and then a motor neuron. And this motor neuron is going back to innervate that same quadricep muscle and telling it to relax. So when that muscle relaxes, the tension and the force going through the muscle, and therefore our Golgi tendon organ, is reduced. But again, because of the location of this reflex in the body, it's involving the knee joint, and our knee joint is controlled by both our quadricep and our hamstring muscles. That sensory neuron can also synapse with another interneuron and another motor neuron, which now innervates our hamstring muscle, and it tells it to contract. So if our hamstring muscle contracts, it forces our quadricep muscle to relax and stretch. If our muscle is relaxed and stretched, it's reducing that amount of tension or force in our tendon reflex. In our Golgi tendon organ. So our muscle spindles detect stretch. So in a stretch reflex, the muscle will contract to relieve the stretch. In a tendon reflex, our Golgi tendon organs detect changes in tension or in force. The tendon reflex will cause that muscle to relax to counteract that increased tension or force in the muscle. The last example I wanted to provide you was our crossed extensor reflex. And this is a contralateral reflex, so it involves both sides of the body. And I'll let you walk through this diagram in your own time as there's lots going on, and I think it might be better for you to have a bit of a read while I'm not talking. But this reflex is triggered, as an example, when you stand on something sharp or hot. In response to this painful or damaging stimuli, you immediately withdraw that leg and foot. But to ensure that you don't fall over, your other leg must extend. So you lift this leg off the ground, but so that you don't fall over, this leg now has to extend so you can balance on that foot. So we call this the crossed extensor reflex because one leg must flex to lift up the foot, while the other leg extends so that you can put it down and not fall over. This reflex is an example of a contralateral reflex because it involves both sides of the body. A polysynaptic reflex because it involves many neurons and synapses with all the flexing and the extending of muscles. And also a spinal reflex because the integrating centre would sit in the spinal cord. We lastly also call it a somatic reflex because it involves skeletal muscle, which usually we voluntarily control, and not a visceral organ in which we have no control over.